Hello students, previous lecture we started arithmetic instruction. Now in this lecture we see the arithmetic instruction, that is the subtraction. Previous lecture we already seen the addition instruction. Okay, so add, ADI, ADC, these are the add instructions. Now in this lecture we see the subtraction instruction. We know in 8085 microprocessor, subtraction 8-bit value or content of any register or even the content of memory location can be subtracted from content of accumulator. The subtraction is performed with 2's complement. Performed with 2's complement. 2's complement form. Also, if the result of the subtraction is negative, it is stored in 2's complement form. Similar to addition operation, no 2 8-bit register can be subtracted directly unless it is subtracted from the accumulator. Okay. Before starting the subtraction, firstly we see what is the 1's complement and 2's complement. Okay. So 1's complement. 1's complement of binary number is another binary number obtained by toggling all bits in it. That is transforming bit 0 to 1 and 1 to 0. Okay. Here transforming the 0 bit to 1 and 1 bit to 0. For example, 1's complement, see here, number binary number 0 1 1 0. Okay. So this binary number 1's complement, 1's complement is, see here, is 0 replaced by 1, 1 replaced by 0, 0, 1. Okay. So this 1 0 0 1 is complement, 1's complement of this number. Okay, got it? What is the 1's complement? 1's complement, 0 replaced by 1, 1 replaced by 0. That is the 1's complement. Now we see 2's complement. 2's complement of binary number is 1 added to 1's complement. What is the 2's complement? 2's complement means 1's complement plus 1 equal to 2's complement. Here, a binary number is 1 added to the 1's complement of binary number. For example, 0 1 1 1. Okay. This is the number, and this 2's complement number is 1 0 0 1. Okay. How it is done? See here, this number, firstly, we convert this number in 1's complement. It's 1 0 0 0 plus 1. Okay, 1 0 0 1. 2's complement number. This number is a 2's complement number. Got it? Now see our instruction. The subtraction instruction. Subtraction instruction, first instruction is a SUB. First instruction, that is a subtraction instruction. The content of any register or memory location are subtracted from the content of accumulator register. The corresponding difference is the same in the accumulator. accumulator register. If the operand is a memory, its address, see here, if the operand is memory, its address is specified by the HL pair. Using this instruction, all flags are affected. All flags are affected. So in this instruction, this instruction is a 1 byte instruction. In this instruction, addressing mode SUBR. Here, register addressing mode is used. If operand is a memory, SUBM. That time, this instruction use register indirect addressing mode. Register indirect addressing. Okay, so the example, see the example here, that is SUB B, register B, the content of register B, and SUB and. See here, in this instruction, the content of register B are subtracted from the content of accumulator. Subtracted from the content of accumulator. So A minus B are results stored in accumulator. Okay. Same here. Subtraction SUB and operand is a memory that time. Result also stored in accumulator. So accumulator and this memory location address specified in the HL register pair. HL register pair. Okay, got it? Now we see our next instruction, that is SBB. SBB instruction. Okay. In this instruction, we use register or memory. Subtract register from the accumulator with borrow considered here. Okay. SUBR, that is the when operand R, a register is used as operand, that time this instruction is subtract register from the accumulator with borrow considered. In this instruction, result stored in accumulator. See here, accumulator can minus here registered minus borrow, or you can see here carry. Subtract from the accumulator. Okay, when use operand and memory is used as a operand, that time subtract the content of location pointed by the HL, that is M, from the accumulator with the borrow considered. With the borrow considered. Okay, so format is A HL minus K. Okay, the content of any register or memory location and the borrow value, that is carry flag is in this case, can use a carry flag in this case, are subtracted from the content of accumulator register. The corresponding difference is saved in the accumulator register. If the operand is memory, its address is specified by HL register pair. All flags are affected using this instruction. All flags are affected. Okay. So all flags linked with the subtraction operation are updated with the result of operation performed. See the example as B B B or S B B M. Okay, using a register or memory. Okay. Now see the next register, that is SUI. SUI. Okay. Here SUI, I means using the immediate addressing mode. 8-bit data. Okay. 8-bit data. Subtract an immediate value from the accumulator. Format is, we know already, result storage accumulator. Okay. Then 8 subtract and data. This data is subtracted immediately. The content of accumulator. The content of accumulator register are subtracted with immediate 8-bit data and borrow value. Here, this borrow value specified by carry flag using the SPI instruction. The answer is stored in accumulator. Using this instruction, all flags are modified or all flags are affected. This instruction is a 2-byte instruction. Addressing mode, which addressing mode is used here? Immediate addressing mode is used in this instruction. And see the example of this instruction, that is SBI 76 hex. That is the 76 hex. Okay. So after that we see the next instruction, that is increment instruction or decrement. Increment or decrement. Every register or memory location hold content of size 8-bit. This content can be incremented or decremented by a value 1. If consider register pair, when the 16-bit content can also be incremented or decremented by value 1. So now we see the incremented instruction, that is INR. See here, first INR operand is register. Okay, INR R, that is increment register content by 1. See the format after increment register here R plus 1. Okay, if operand is memory, increment the content of the memory location pointed by the HL pair by 1. The INR command used to increment, that is increase the content of register or the data and location pointed by HL pair, that is M by 1. The result stored in the same location itself. Result stored in same location itself. In case of operand being M, the value at the memory location given by HL pair is incremented by, HL pair is incremented by 1. The value in the HL register pair does not change. And this instruction size is 1 byte instruction. How many byte instruction? 1 byte instruction. All flag are affected except the carry flag. In this instruction, all flag affect except which flag? Except carry flag. except carry flag. In this instruction, carry flag is not affected using this instruction. For example, INRB. Using this instruction, content of register B is incremented by 1. Okay, incremented by 1. If operand is memory, here use memory. That time the operand M, the value of memory location given by HL register pair, increment by 1 here. Okay. Now after that we see our next. See the example here again. If INR using M, okay, M equals to 7500 hex, okay, and value at 7500 hex contain 03 hex. Then after execution, this 7500 hex contain 04 hex. Okay, this location incremented by 5. Okay, got it? Now we see next instruction, that is INX instruction. Here this is the INX R. Operand is R. Okay. So increment the content of register pair. We already seen X. That means here register pair. INX instruction, increment the content of register pair by value of 1. Here the result stored in same place itself. This is the 1 byte instruction. This instruction is a 1 byte instruction. So format is a RP, register pair. Plus 1. Okay. This instruction is a 1 byte instruction. Okay. Which addressing mode is used? Here we use only register. That's why register addressing mode is used. How many flags are affected in this instruction? No, any flag is affected using this instruction. Okay. No any flag. Here. None. Flag is not affected using this instruction. For example, INXB. B means register BC, register pair BC. Okay. So next instruction is DCR instruction, that is a decrement instruction. DCR, operand register or maybe memory. Decrement register content by 1 if operand is register, that is the R. Okay. Decrement register content by 1. Format. So result stored in same place. Okay. If operand is memory, that time HL minus 1. Decrement the content of memory location. The operand is M here, DCR M. Okay. Decrement the content at the memory location pointed by HL pair by 1. Okay. See the format. This DCR command is used to decrement or you can say decrease the content of register or memory location by value of 1. The result after this operation is stored in same location itself. Same location itself. Okay. If the operand happened to be a memory location, its address is then specified by location HL register pair. Here, this instruction is a 1-byte instruction, and addressing mode when we use DCRR. At time, this instruction is a register addressing mode, and DCRM, this instruction is register indirect addressing mode is used here. Okay, in using this instruction, all flags are affected except carry flag. And using this instruction, carry flag is not affected except carry flag. Okay, got it? All except the carry flag. Now, next is for example, DCRB or DCRM. The example. Now we see next instruction, that is DCX. DCX instruction, DCX instruction, operand is R. Decrement register pair by 1. Here RP, you can write here RP register pair. DCX instruction decrement the content of register pair by value 1 and result stored in same place itself, that is RP minus 1. Okay, here 1-byte instruction, addressing mode, register addressing mode is used here. Okay, and using this instruction, no flag is affected. Okay, no flag is no flag is affected. And for example, DCXH, that means HL register pair. Okay, so these are the subtraction instruction and increment or decrement instruction. Now next lecture, we see the remaining instruction of 8085 microprocessor. So we stop here. Thank you, students.